So in the last class, we were discussing about the different types of constants. Also, we discussed about the enum and void data type also. So the what is void data type, then what is an enum data type that we have seen. Then we saw something about the constants, the different types of constants. They are numeric constants, that is the integer and the floating point constants. Then the character constants, the three different types of character constants, that is like character constant, then the string constants, then the escape sequences, or also known as / character constants. So up to this we have completed. Now what we will see is the input and output in C programming, that is how the input is taken and how the data is output from the C programs. So input means the data is read into or read by the program, and output is the data is fed out by the program. So how this is being done, we can discuss. So there are actually three different devices in the in the C programming or C compiler. There are three different devices. The stdin, stdout, and the stderr. These are the three different devices that is available in C programming. So these three devices are stdin means the standard input device. Usually the standard input device will be your keyboard in most of the cases. In majority of the cases, the standard input device is your keyboard. So when we say that some data is input by the user, in a C programming, if we say that some data is to be input by the user, what it means is that the user has to type in something. So the user has to type in something using his keyboard. So that is it. So that is stdin, the standard input device. Then the stdout, that the std output is the standard output device. It is usually the monitor. In most of the cases, it is the monitor that can be changed, or in some high-end programs that can be changed to the printer also, no problem. But in the most cases, in the cases like what we are doing in the simple programs, the standard output device is usually the monitor. So whatever output, if we say something is to be output by this particular program, that output will come on the screen. So that is on the monitor, because it is the standard output device. Then stderr is the standard error device. Again, it is usually your monitor, because the standard errors, the most of the errors that is being displayed or that is being happened inside a C program, they are displayed on the monitor itself. So it is the standard error device, that is the monitor. So there is standard in, standard out, and standard error. So these are the three devices which is opened automatically by C programs when it tries to execute. That is, when a C program starts executing, these three devices, stdin, stdout, and stderr, these three devices will be opened automatically. So now let's see how the data is output by this C program. We have seen many printf statements. The printf statement actually gives you the formatted output. The formatted output is created using the printf statement. So within the printf statement, we have to give some specific parameters so that it will print, it will display on the screen in a specific way. So the printf outputs text to stdout. So printf normally gives the output to the standard output device. In our case, the standard output device is stdout. That is, the stdout is our monitor itself. So the printf statement displays what our message is given as the argument to that particular function is displayed on the screen. So the basic function printf is of the form. This is the basic format that we normally use. This is the format printf. That is the function name. Then for each function you need the parenthesis. The parenthesis is required for all the functions. So the parenthesis starts, and within this printf statement, that is within that particular parenthesis, you have to specify the format, that is how it should be printed, then the argument 1, the argument 2, etc. So the number of arguments depends on the number of elements that is to be printed. If it is only a single element or only a single statement, then only a single argument is required, that is within brackets, within the semi double quotes, within double quotes what is to be printed can be given. And otherwise, if you want to print some values, display some values of some variables, then in that case you have to give the format specifier that we have already seen, that the %d, %s, %c, etc., etc. So that sort of thing also you have to give. And then the arguments occupies the position of this format control strings. So that's it. So the format is actually whatever this format. The format is a string which contains the conversion specifications. The conversion specifications is the format control strings, that is the format specifiers. Then the literals to be printed. The literals are, we have seen that literals are the constants. So the constants that are to be printed on the screen, they are inserted inside the double quotes. So that is that can be printed, that will be displayed on the screen. So then the printf conversions, the conversions are the specifications which begin with the percentage symbol. So that is the format specification symbols, the format specifiers. The format specifiers always starts with a percentage symbol and end with a conversions character. So it always starts with a percentage, that is like a percentage D or percentage S or a percentage LLD, etc., or percentage LD or percentage LLD, etc. So this starts with a percentage character. In all the cases, it starts with a percentage character and ends with a conversion character. So here this is S, here it is D, here also it ends with a D, etc. So between the percentage and the conversion character, there may be in order a minus sign specifying left justification. That is, we are writing something like this. That is 1, 2, 3, 4.0, etc. We are writing. Then at some point we want to write something in such a way that it is justified towards the left. That is, it is towards the left, 1, 2, 3, 4.0, something like this. If you have to do something like this, then what you have to give is you have to give a minus sign specifying the left justification. How this is being done, we will see in a program. Then the minimum width field, that also can be given. That is not necessary, but that can be given, like a percentage 8D. This means 8 characters will be reserved, or 8 spaces will be reserved for the value that is to be printed. So it can be an integer without having only 3 spaces. That is, say it is a 567. If this is the integer that is to be printed, so if it is given as percentage 8D, then what happens is it will give 5 spaces. So the 5 spaces will be given, will be left, and on the 6th space it will print as 5. Next it is 6, then 7. So this is how this will print, this percentage 8D. Instead, if it is given that percentage minus 8D, so that is a minus symbol, so it has to be left aligned. So what it will be printed will be 5, 6, 7, and then the 5 spaces. So this is how the left justification, that is minus symbol, is used, and the number is used, that is the minimum field width. So a period separating the field width and precision. So it is something like this, percentage 8.2F. So this is a floating point value. 8.2 means 8 characters will be taken for printing this, 8 spaces will be taken for printing this particular floating point values, out of which 2 will be decimals. So like if it is 567, if we put 567 with a specifier like this, then what it will be printing will be 567.0 0. So there are 2 decimals will be printed, and there will be total of 8 spaces will be taken. So here it is already took 5 spaces, and 3 more spaces will be left like this. So 3 spaces, then 5, 6, 7, then dot 0, 0. So that is how the floating point values are displayed using the precision also. So this precision means how many decimal digits are required in our representation. So in most of the cases 2 will suffix, but in some cases you may need, say, up to 4 different digits. In that case you have to replace this 2 with 4. So it can be something like this, percentage 7.4. So out of which out of the 7 positions that is available, 4 will be taken for the decimal points. So the precision that specifies maximum characters in the string. So the maximum characters in the string is this one, and the number of digits after the decimal for a floating point, that is this one, the number of points after the decimal. The maximum digits, number of digits for an integer. If it is for an integer, it can be like this also. That is only percentage 8d. So it will be for integer type values. That is only 8 spaces will be reserved for that particular integer string, I mean integer value. Then it can be an H or a short for short, or an L for long. So like this one, percentage LD. So that is for long. D means integer. So it is for long integer. Long integer is double itself. So it can be LD also. So LD is for integer, the long integer type. So these are the printf conversions. The common printf conversions that we have already seen, the format specifiers. So not the format specifiers. In the format specifiers we are using, and not the format, the escape sequences. The format specifiers we have already seen, the percentage D symbols, or percentage the characters starting with a percentage symbol. So it is percentage D. The integer argument is printed as a decimal number. Then it can be percentage U. The integer argument is printed as an unsigned number. That is, if the number is signed with a plus or minus, plus 567 or minus 567. So this is a signed integer. So if we put it like this, if we put percentage U symbol, and with that one if we put plus 567, in that case the integer will be printed as an unsigned integer. That is only 567 will be printed. So this is an unsigned integer. So then percentage S, it prints characters from the string. So until a null character, we have seen that this particular symbol, that is this particular backslash constant, backslash character constant /0, /0 is seen, or the number of characters in the optional precision have been printed. More on this later. So that will be discussed later. So the percentage S normally prints the characters within the string, and all the character strings, the strings end with a percentage 0. Even though we doesn't input a /0, all the character strings will end with a /0, that is a null character. So using that or utilizing this particular property, that is a /0 is towards the end of each strings, we can determine whether the end of the string has been reached or not. So that is in order to print the strings, we use percentage S. Then percentage F is the double argument. So it is printed as a floating point number. So it is we have seen for printing the floating point numbers, you have to use percentage F. Then there is percentage X and percentage capital X. So these are mainly used for hexadecimal number. And for the hexadecimal number, in order to represent that this particular number is a hexadecimal number, we normally put a 0x in front of that particular number. So if it is 0x5, this means this is hexadecimal 5, or 0x say 12. So this means this is the hexadecimal 12. Otherwise, if we just write 12, this means this is decimal 12. So there is some difference associated with these things, that is hexadecimal number as well as the integer, the decimal numbers. So in the case of 12, etc., it is the same, no problem, but something like 25, 0x25. So whatever is greater than 16 or 15, it is different. For 16, it is taken as A. Sorry, for 10, it is taken as A. For 12, it is different. So that's how the hexadecimal digits are represented. 0x will be printed in front of thing. But when you use this particular format specifier, that is %x or %X, this leading 0x won't be printed. This value, this won't be displayed on the screen. So then %c for the integer argument is printed as a single character. For a single character, if you want to output a single character, in that case %c is used. Then %p is for pointer argument. So it is the implementation dependent. The implementation dependent means depending on the type of system on which the program is running, the %p may work or may not work. So that's the thing about the printf statement. Now let's see some of the examples, how this printf will work. So here is a program. This is a program that is used to explain the printf formatting. So in this case, actually, I have included another header file, that is #include stdio.h. This is a preprocessor directive, that is #include stdio.h. Our usual preprocessor directive, that is include stdio.h or stdio header file into our program. In this case, I have included one more header file into our program, that is math.h, #include math.h. This math.h is used in order to include some mathematical functions into the program. So the mathematical functions like sine, cos, or square root, etc. are defined inside the math.h. So in order to use those type of functions, you have to include that particular the header file also into your program. So I have included this math.h also. So then we start with int main void. Then I declare two integer variables, anint equal to 5678. So anint is an integer value, so it is 5678. Then int I is taken as not initialized, there is no initialization. Then a double value is also taken, that is a double. So that is a double is this particular thing, this a double, that is the name of the variable, that is 4.123. Then a constant is also defined. We have seen in the previous class, then using the #define preprocessor directive, you can define constants. So here a constant is defined, the name of the constant is name, and the value for that particular constant is both. So this is the thing that is defined, that is %define name both. Then #define. So this is a preprocessor directive. Then we have given some printf statements. Let's see what each printf statement will print. So here printf %d is a large number than anint. So obviously this %d is for integer conversion or integer numbers, and here it is also an integer number. So obviously it will print 5678. Then printf %8d is a large number, then again anint is to be printed. So see, this is how the printf statement works. The first one, the %d, in the position of this %d, the value of anint will be printed. So here the %8d, 8 spaces will be stored for printing the value of 5678. So since it is having only 4 digits, the 4 spaces will be left before that one, before printing 5678. And here this printf %-8d, it is again a large number. So the statement is it is a large number. So it is again an int. We are printing an int there. So this is, since there is a minus symbol, it will be printed at the first. It will be left aligned. The statement will be left aligned. So 5678 will be printed first. Then the 4 characters will be left. Then is a large number. That is how it is going to be printed. Then printf %10 going to 2f is a double. So here the double number is printed, a double. So in this case, 10.2 means that 10 spaces will be reserved for displaying that particular number, out of which 2 will be the decimal points. So out of this, this has actually 3 decimal points, but only 2 decimal points will be displayed there. Then in the third statement, it is the sum of percentage %d and percentage %8.4f is percentage %12.2f, a anint, a double, anint plus a double. So here there are 3 format specifiers. This is the first one, that is percentage %d for an integer number. So here this particular value will be printed. This anint will be printed in place of, or displayed in place of percentage %d. And here it is percentage %8.4f. That means 8 spaces are reserved, out of which 4 spaces will be for the decimal digits. So here it is 4.123. So another 0 will also be printed towards the end, because 4 spaces are reserved for the decimal part. Then is percentage %12.2f. 12 spaces, out of which 2 will be reserved for the decimal points, and it is a floating point. So this is a floating point. This is also a floating point. And here what will be printed is anint plus a double. So the sum of these two values, the integer value as well as the double value, will be printed here. So whenever we are adding an integer value to a double value, the value automatically, the sum will always be a double value. That is why it is also taken as floating point f. So then finally we print hello percentages. Percentages is for string. We have already seen that percentages is for string. So here the name will be printed. In this case, in this particular case, the name is Bob. So Bob will be printed here. Then after that, a particular line will be displayed. This line actually represents only the number of spaces. One is the first space, then 2, then a space, then again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That instead of 10 it is 0. So that is 10 spaces are left there. Then again another, here it is 20 spaces. So that is 2 spaces, then 10 spaces, then another 20 spaces are reserved. So in that case, what it will print inside this one is, it is actually taking the values I equal to 1 to 5. 1 to 5 is taken, and then what it does is it finds out the square root of 5. So it is square root of 5 is printed twice using 2 different methods. So percentage %2d, this is first percentage %2d. In that case only the decimal value of I is printed. So it is 1, 2, 3, 4, 5 that will be printed. And here percentage %10.6f. 10.6 means 10 spaces, out of which 6 space will be for decimal digits. And here it is percentage %20.15, 20 spaces, out of which 15 spaces will be reserved for decimal points. So that is why here is a 10 space. This 10 space corresponds to this 10. Here is a 20 space, and this 20 space corresponds to this 20 space. So let's see how this will work. Compiled it, then run it. See how it is coming up. 5, 6, 7, 8 is a large number, because the particular statement in that case was only only percentage %d is a large number. So it is directly printing 5, 6, 7, 8 is a large number without no change. But in the case of print of percentage %8d is a large number. So there are, see, 1, 2, 3, 4. 4 spaces were there, and all those 4 spaces were left. And then we start with 5, 6, 7, 8. So 5, 6, 7, 8 is a large number. Then -8d. So here -8, we said that -8 will align the number to the left. So this is here 5, 6, 7, 8. So it is left aligned. 5, 6, 7, 8. Then 4 spaces is there. See, this is a large number is aligned, in both the lines, So that is how we know that there are 4 spaces left. Is a large number. Then the next line, this is 10.2f. 10.2. So up to here, up to this point, it was 8 spaces, and then again 2 more spaces. This space as well as the next space. So 2 more spaces are left taken. and so out of which 2 spaces are given for the decimal points. So it is 4.12. So 4.12 is a double. So that's it. 10.2 is a double, and 4.12 is a double. So the last digit 1, 2, 3 was the actual number. So that 3 is truncated here. Then the next statement, that is the printf the sum of percentage d, the sum of percentage d in the space of percentage d anint is to be printed. So we put the anint here. So anint, that is 5678, is printed, and then percentage 8.4f. So here there will be 8 spaces left, and out of which 4 spaces are for the decimal points. So 4.123, and only 3 decimal digits were present. So the last digit is replaced with a 0. 0 is then percentage 12.2f. So percentage 12.2, 12 spaces, out of which 2 will be decimal, and the value that is to be printed, there is the third argument here. So this is the format, this is the format, and this is the first argument, this is the second argument, and this is the third argument. So here in this case, the third argument is anint plus a double. So anint is 5678, and that a double is 4.1230. So adding those two, 5682.12. So because there are only 2 spaces left for the decimal points, only 1, 2 is printed. Then in the next line, printf hello name. So the name was Bob. So that is replaced here. Percentage s is replaced with the value or value of name. The value of name is Bob. So hello Bob. What it is printed is hello Bob. Then this particular line 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So that is printed twice. Then it is percentage 2d. So 1, 2, 3, 4 is printed using the percentage 2d. So only the right hand spacing is space is used for printing the decimal, I mean the integer values. Then the square root of that particular value, square root of 1 is taken in a 10 space wide field, out of which 6 spaces are reserved for decimals. So here will be 6 decimal spaces, 2, 4, and 6. 6 decimal spaces are there, or decimal digits are there. So that is how it is 1.0000. So that's it. Then here it is 15 decimal digits were there. So there are 15 different zeros will be there. So that is how the printf statement works. So the first format specifier will take the first argument, and the second format specifier will take the second argument, and the third format specifier will take the third argument. So that is how it goes on. How many arguments are there, that many format specifiers are there and are required, and how many depending on the number of format specifiers that is included within the format, you have to include that many number of arguments also. So that is how the printf statement works. Now let's move back onto our presentation. And now we move on to the keyboard input. Keyboard input is, we said that the standard input device is the keyboard. So using the keyboard in order to take in data, that is if the user has to, if any user has to input some data, then the function that is being used is the scanf function. So scanf reads the user input from the stdin. The stdin is the standard input device. So that is keyboard in most of the cases. So the scanf reads this user input from the stdin, the standard input device, that is the keyboard. Then the calling the scanf is similar to calling the printf statement. It is almost the same thing. The only difference is in the case of arguments, the arguments are the addresses of those variables, not the variable names itself. In the case of printf statement, we are printing the variable names. We are directly printing the variable names without, I mean, we are just typing the variable names. But in the case of scanf statement, the variable names should be preceded with an ampersand sign in order to represent that it is the address of that particular variable. So the address of that particular variable, that we will see there how the what is an address. We have already seen what is an address of the way of a variable. That is, the variable is stored inside a memory space, and the address of that particular memory space is the address of that particular variable. So while assigning a specific variable, while declaring a specific variable, we assign a memory space. Some memory space is assigned for that particular variable, and the address of that particular variable is, the address of that particular memory space is the address of the variable. So in the case of scanf statement, the arguments are the addresses of the variables. So let's see how this is being done. So the scanf format string usually contains conversion specifications that tell the scanf how to interpret the next input field. That is what we are typing in, how it is to be taken, whether it should be taken as a character, or it should be taken as a string, or it should be taken as a numeric value, an integer, a float, etc. That will be decided by the format specifier that is included within the scanf statement. So normally an input field is a string of non-white space characters. The white spaces will not be taken in using the input field unless you are typing a string. Unless you are typing in a string, the space character will not be taken by the white space character will not be taken by the input field. The format string in scanf consists of blanks or tabs which are ignored. So the format string usually contains blanks or tabs, but it is usually ignored. Then ordinary characters which are expected to match the next non-white space character input by the user. So ordinary characters, whatever the ordinary characters that is available in the character set, that should be input by the person who is the user. Then the conversion specifications usually consist of the percentage character, as in the conversion specifier what we used in the printf statement. Here also the percentage character is required, the beginning of the conversion, and the optional H or L. So a conversion character which indicates how the input field is to be interpreted. So that is how the scanf works. So that common scanf conversion factors are the same as this is the same as in the previous case, in the case of the printf statements. So let's see how this scanf works. How the scanf works. Let's see using an example. See, here is again, here also I have included that math.h. Actually, that is not desired in this particular condition, because the there is no specific function is from the math.h header file is used, but let it be there, no problem. So then defined the integer value, but the initialization was not done. Int value, an int is there, but no initialization is being done. And I value is there, so that is also not initialized. That is actually not being used in the program also. That is the I value is not being used. We can delete that value. It's not being used. And this include a math.h, that is also not being used. So that also can be deleted. So there is an int, an integer value, then a double value, then a character string, that is name. It is having a width of 20, then up to 20 characters it can store. That is why there is a value 20 is specified here, because the name variable can store up to 20 characters. After that, it won't be able to take in the value. So an integer value, the variable name is int, and a double value, the variable name is a double. So now what the program does is it displays something to the screen, enter an integer. So we have to enter an integer while it is being displayed. So then whatever integer value that we enter on the screen or using our keyboard, whatever integer value that we input using our keyboard, that will be read into an int. So that is how this particular statement comes. So this is the format %d because it is an integer. An integer value is to be input. So that is %d. Then ampersand and int. So this ampersand means it is giving and it is the address of that particular value, the address of that particular variable. So ampersand and int means it is the address of the particular variable. So that means whatever value that we are inputting, it is inserted into the address into the memory location of that particular variable. So this means the address value of that particular variable name, ampersand and int. So in the scanf statement, this ampersand is a must. Then printf, enter a double value that is displayed. Then the scanf, here the %lf is used because we are taking in a double value. So it is %lf is used. Then again, here also there is the ampersand sign symbol. So ampersand a double. So then enter a name, that is string. A string is to be inputted. So then it will scanf that particular value. Since it is a %s, that is a string. The string is read. It is stored into name. Then the values are displayed as in the previous case, the %d. So let's see how this will work. So enter an integer. I am entering an integer, say 68. So an integer is entered. Then enter a double value. So I enter a value, say 52.689. So enter the name. A string is to be printed. I am typing in A, B, C, D, E, F, G. That is just any name, any string of characters. Then I am pressing the enter. Then C. 68 is a large number. So this is how the printf statement works. The printf statement, as we have seen in the previous case, the same printf statements are there. So we have entered the integer as 68. So 68 is a large number. Then this is towards the right, that is %8d, that is 8 spaces are left. So 68 is a large number. Then here it is %-8d, so that is left aligned. So 68, then the 6 spaces is a large number. Then this is 10.2f is a double, so that is 52.69 is a double. Then the sum of %d and %8.4f is %12.2f, so it is written here. The sum of 68 and 52.6890 is 120.69. Then finally the hello A, B, C, D, E, F, G. So that is it. Then one thing, see here it is 52.69. Actually we have entered 52.689, but here it is 52.69. Why is it so? Any idea? It's because of the truncation. It is because of the rounding off. When 52.689 is truncated to or rounded off to 2 decimal digits, what happens? It is rounded off to 52.69. That is our common rounding off procedure. That is what is happening here. So that is why it is 52.69. So then it is being added. 52.689 and 68 is added. So it is 120.689. So here also that only 2 digits are there. So it is 69.69. 120.69. So that is all about the printf and scanf statements.